Okay, so hold on a second. So what I wanted to show was how to do this graph after number 2, so that you can see how to graph this thing. And there's a couple of pieces that I really want you to pay attention to, specifically pertaining to this problem, this specific problem, okay? So the very first thing that I notice is, hold on a second. The very first thing that it says is, model the number of push-ups Scott will complete on any given day, include a table, a graph, and both equations. So we've already done a lot of the work, right? We already came up with the recursive formula. Remember that the recursive formula has 2 parts, the starting points and the actual rule. Remember, we noticed here that this +2 keeps showing up everywhere. Like he's like the star of the show, remember? And that makes sense because this is called our slope. It's called our rate of change. It's called our constant difference. Okay, so the second part of this, let me see here. So then they wanted us to create a table, which I don't think we actually created a table. So let me create a table really quick. So table, and I'll go like this, and up here I will put, is this the number of days? Yeah. And then this is the number of push-ups, right? Yeah, I could do that. If you could just add it to the OneNote, and then I'll keep track of it there. Okay, so the first day he has 3. So first day Scott does 3. On the second day, wait, hold on, I'm gonna just go this way so that it's easier to fill in. Oops, just kidding. In fact, okay, on the second day right here, he does 5, and then he does 7, and then 9, and then so on, right? So there's my table. So then it says, now make a graph for it. Now the graph is going to be interesting, and I want to show you why it's interesting, okay? So when I graph this, so here's all my work up here. So when I graph this, I'm going to actually graph these points up here onto the table, which that makes sense. That's not a big deal. Ms. Johnson, what's so interesting about that? So this is going to be days down here. And this is going to be the number of push-ups. Okay. And then I would draw my axes in just so that they're straight, but I'm not going to. I'm just going to go here with 1 and with 1. And I usually label my axes with just 1 unit of 1 so that everybody knows that each of these squares going this way is 1, and each of the squares going this way is 1. So on day 1, I have 3 push-ups. On day 2, I have 5. On day 3, I have that many, and you guys can kind of see the pattern as I continue drawing these little dots. Now, this is a part that I want to make sure that everybody's listening. So if you're not listening, listen. Okay, so this right here, I know you want to go through and you're like, oh wait, hold on, it's not drawing all my little dots. Okay, come on, bud. Okay, there that goes. So here you see all my little dots that are appearing as my number of push-ups. So you should know that like this dot right here, because it's 3,7, means that on day 3, I did 7 push-ups, right? On day 3, I did 7 push-ups. Okay, so the part that I want to get to here is this. I know you want to connect your dots, but for this context, that doesn't make sense, right? For this context, that doesn't make sense. But Johnson, why doesn't it make sense? Because, okay, so don't connect points. And the reason why you're not going to connect your points is because if you connected your points, now I'm going to put a point in between. I'm going to put a point like right here, which technically it belongs there, right? But like this one meant on day 3, I did 7 push-ups or whatever. Scott did 7 push-ups. What does that point mean? And you'd be like, on day 1.5, I did 4 push-ups. That doesn't make sense, right? So don't connect these dots because the in-between dots don't make sense in this context, right? The in-between dots don't make sense. So we call this discrete. Everybody say the word discrete, discrete, discrete. Oops, I almost had an extra letter in there. Discrete means that we don't connect our points, or the points are not all connected. Okay, so this is a big deal when it comes to later on in math. So right now for us, I just want you to know, hey, why don't we connect these points again? And you would say something along the lines of, well, like 1.5, 4 kind of can make sense, right? Like at the middle of the night, he got up, he did 4 push-ups. I don't know. But this one right here, if I added this other, like say a purpley point right there, do you see my little purpley point? It's going to appear right here. Actually doesn't make sense, right? Because how do you do, okay, like on day 1.25, you're doing 3.5 push-ups. And some of you are funny because you're going to be like, yeah, Ms. Johnson, like a half push-up is like when you're on your knees. Technically, that's still just a push-up. It's just it's a modification, right? So there's no such thing as a half push-up, just like there's no such thing as a half phone or a half of a bike or a half anything. So because this in this context, it doesn't make sense for us to connect the points. We don't connect it, and it's therefore called discrete. So everyone say the word discrete. Discrete. Okay, Ms. Johnson. So what if we did connect the points? What would that be called? Well, in that case, right, it would be called continuous. Okay, so the word continuous means just that. It continues. Continues. That's actually funny. Okay, so it just continues. So if I was to connect the points right here and it looked like a line like this, do you see how this would be considered continuous and this is not continuous? So the little picture that I want in your head about continuous is this. If your function, this is your function, this is your function, looks like a good set of roller coaster tracks, like this is a roller coaster track, this is a roller coaster track, then it's called continuous. This is a bad set of roller coaster tracks, okay? Like, don't get on this roller coaster. Why not, Miss Johnson? Because there's holes in between the 2 tracks. That means you're gonna fall. That's not good. We don't want you to fall. We want you to be whole. Good? Okay, so that's what the difference is between continuous and discrete. So here's that graph for you. Make sense? Yay.